All right, this is JV statistics. We are doing chapter 17. We're in inference right now, and it's gonna be pretty cool. So again, stop the recording as much as you need to because it does take a little time to write stuff down. We're talking about hypothesis testing in the 4-step process. I have a 5th step, as you can see there. I will circle that real quick. This 5th step really isn't a part of the steps. It's just something that could happen, especially when you get into advanced placement. You can see what's new and what's not. So we covered the conditions and assumptions and requirements in the last chapter. So again, assumptions, that word comes about because you got to have requirements like minimum sample size, like representative sample. You got to have that to do a study. And if you don't know if you have that, you often assume that you do. So there's the word assumptions, okay? So, so let's go ahead and get started, all righty? So the first step is to state the hypotheses. That's called HO and HA. HO is called H naught or null hypothesis. Maybe the better word in modern English would be original hypothesis. That's the default position. Okay, usually means no effect. I'm down here, and it usually means no effect, or everything's the same, or there's no change, everything's normal. Don't worry about this. That's just kind of weird thoughts that I have when I lecture. But in any event, that everything is just kind of the same. Okay. HA is that there is an effect. Something is going on. There's a change, a difference, something like somebody's guilty. Because when you first in the court system, you assume they're all innocent. Okay, we talked about that in class a little bit here and there, but they're called HO and HA, and we're going to be doing proportion tests. So you're going to do P equals. You can also do pi equals. Pi is not just 3.14. It's just the Greek letter P, and in this case, it means the true proportion. Okay. And then this could be greater than, less than, or not equal to one of those three. We'll talk about that. Then you're going to state your assumptions as part of the everything that we do. And the assumptions, it's the SPIN acronym with the, we'll talk about that in a second, or let me just go ahead and slide down so you can kind of see that. All right. So the, if you remember the SPIN acronym, the S stands for representative sample. You got to have a representative sample or a well-done experiment. The population needs to be at least 10 times the sample size. Each event has to be independent, and then we got to have enough samples. And this is the little equation that helps you remember that. N times P has to be bigger than 10, and N times 1 minus P. 1 minus P is Q. It's got to be bigger than 10. So again, when you're doing this, step 1 is to write out HO and HA, ho and ha, what we often call them just colloquially. Then state your conditions. Then you're going to do your test statistic, and your statistic is going to be the p-value is what we're studying right now. And then I have a sentence frame for you for what's right for your conclusion. So those are the 4 steps. And then it's possible that you made an error. Whenever you do a study, errors can happen, and they're labeled as type 1 and type 2 errors, and we'll talk about that. Okay, so there is the beginnings, a process of this. I'll do four different problems at the end of this. Okay, step 3 is something that's actually old. We've actually done this before. We did this in way back in the very first section of the course. Okay, so this is something you've actually done. So that's step 3, is calculate that statistic. Step 4 down here is to be able to write your conclusion. Your conclusion is going to have a sentence frame. It's going to be, if the p-value is low, you're going to reject HO. That actually rhymes. The p-value is low, reject HO. And then you'll say sufficient evidence to conclude ... and you'll write in context. If the p-value is high, your first sentence will be fail to reject HO. And then you'll say there's insufficient evidence to conclude, and then you'll write whatever is HA in context. Okay. And just a couple of small notes. That's pretty important. Again, it's more important in the AP class than it is in this particular class. But the meaning of p-value, The meaning of p-value is the p-value is the probability of something happening by chance alone. Okay, so basically, p-value is the probability that something happens by chance alone. And if it's super low, then you realize chance probably isn't the reason, it's something else. That's the concept behind it. And the phrase statistically significant means it's too unlikely to happen by chance. Thus, we're going to reject HO because we have statistically significant evidence, okay? Set 5 here. If you reject HO, it's possible you have a type 1 error. Okay, so it's possible you rejected HO and HO was really true. If you fail to reject HO down here, it's a possible type 2 error. Now, keep in mind, for the most part, statistics produces correct answers provided you meet all the requirements of a study. But once in a while, you have errors, and they're labeled as type 1 and type 2 errors. Okay. So with that behind us, let's go ahead and get started. So we're going to do 4 problems. Yeah, 1, 2, 3. We're going to do 4 problems. You know, it's all scripted for you. Okay. So here's the first problem. A drug company claims that people suffer side effects of their cholesterol 8% of the time. That does happen. Of the 150 people who took the drug, 18 side effects. Is there evidence to suggest the rate is higher than stated? All right. Step 1, write out HOHA. P is 0.8 or P is greater than 0.8. No problem. And the reason we put greater than, because it says higher than stated. Okay. Now, I'm going to write out my 4 assumptions. I bullet point them. I don't want to put the SPIN acronym. I don't want to write SPIN and just for you to memorize. Okay. Assume we have a representative sample of drug takers. Fine. Assuming the population is at least 10 times N, so we had 150 people, there's probably, surely there's 1,500 people that have taken this drug. And assuming each reaction to the drug is independent, now see if we have enough samples. 8% times 150 is greater than 10, and then 92% times 150 is also bigger than 10. We're good, we have enough samples. Okay, now, what you're going to do now is a couple of ways to do this, but the quickest way is to use the program on your calculator. I'm going to bring that in here. So what we're going to end up drawing out, and let me go ahead and look at it here. This is your Z statistic. Your stat is 12%. By the way, where did I get 12%? 12% is 18 divided by 150, just so you know, that's way back up here. 18 divided by 150 is 12%. Okay, so 12% minus 8% divided by the standard deviation, which is right here. So our Z-score is 1.8. Is that unusual? Not really, because remember, unusual is about 3 standard deviations away. So that p-value comes out 0.0355. Let me show you the fast way to do that, okay? And let's try this, okay? So let me bring in the calculator, okay? Here's the calculator, and this will be the fast way to do this. There's a slow way too, which is in chapter 1. You can go stat, and then you're going to go over to tests, and you're going to go down to 1 prop Z test because we're doing a proportion. So go right there, hit enter, and now 0.08 was what the hypothesis was. And then there were 18 people out of, I think it's 18 out of 150. Yeah. 18 people out of 150 that experienced this side effect. And we're looking for greater than right there. Okay. And then we're going to go ahead and click draw. Check this out. This will do it. Uh-oh, what did I do wrong? I'm going to go second. Make sure your stat plots are off. 4. This is actually good for you to remember. Okay. Stat, tests, 1 prop Z. Should all be there still. Yep, it's all there. All right, that was a good error. You guys can learn from that. Hit draw, and there we go. So it comes out 0.0355, meaning there's a 3.55% chance that we get this data just by chance. Okay. So what we're going to do is we're going to go ahead and draw that out on here on your notes. Okay, so we're going to draw that out. Okay, so this is 0.08 and then it was 12%. And then this was the standard deviation right here. And then the z-score was 1.81, and the p-value was right here, 0.0355. You can draw that right there. Okay. Now, there's something called alpha levels. Look at the conclusion right here. I'm right here right now. Conclusion. Proof levels are, generally speaking, there are two of them, 1% level and the 5% level. If you want more proof, that's the 1% level, because it's harder to get a p-value inside of 1%. I just put this as 5% just to do it, so we can reject HO. Because 0.03 is less than 0.05, I'm going to reject HO. And I'm going to say, let me slide down, let me clear the drawings. And I'm going to say, we have sufficient evidence to conclude HA. Okay. And when you reject HO, there is a possible type 1 error. Okay. All right. Let's try the next one. Okay. So we move this over just a little bit. Here's the next one. Casino game Wheel of Wealth claims that a cash prize of $100 or more is awarded 30% of the time. However, a gambler tracked the last 80 spins and noticed that there were only 21 cash prizes of $100 or more. Is the casino game inflating their proportion of wins? Is it inflating that? Okay. All right. So HO, P is 0.3. I think that's pretty easy to see. And HA, inflating, the word inflating is another word that means that they're saying it's too high. So we're thinking it's less than 0.3. Okay. Here's our assumptions. Here's the S in spin. We have a representative sample of spins games. The wheel could for sure be spun more than 800 times. That's 10 times 80. And each prize or spin is independent, no problem. And here's NP greater than 10 down here. I'm down here, and N1 minus P greater than 10. So I have enough samples. All right. So again, let's try to do this. Okay. So 21 out of 80, claiming it's 30%. So let me bring in once again the calculator and see what you can do here. So we're going to go stat tests, one prop z test. And this was 0.3, and this was 21 divided by 80. And we're wondering if it's actually less than. Okay, just following the prompt, and then boom, there you go. And the p-value is pretty big, so this would happen 23% of the time by chance. 23% of the time by chance is definitely not evidence to suggest that it's actually less than 30. This is explainable by chance. Okay. All right. That's one of the big phrases. Is it chance in statistics, or is it change? Chance or change? All right. So let me go ahead and draw this. Okay. This is preferably how you do this. Okay. So remember the raw score, 0.30. Then it was 21 over 80. Okay, and then this is your standard deviation that goes right there. And the z-score was negative 0.73, and the p-value was 0.2321. Okay, that's pretty sloppy, but you get the idea, I think. And again, because that is higher than 0.5 or any alpha level that we use, which is only 2 of them, we're going to fail to reject this. We do not have evidence. And let me slide down. Let me clear this and slide down. We do not have, we have insufficient, I should put the word evidence. We have insufficient evidence to conclude HA, which is that it's inflated. Now, when you have insufficient evidence, where you don't detect something, that is a possible type 2 error, meaning it could actually be inflated, but you didn't detect that. Okay, we'll get into more of those later. Okay, next one is C. 2 more. John is considering running for ASC president. A random sample of 40 students shows 16 of them would vote for him. Should John still consider running, or should he suspend his campaign? Ooh. Well, we're assuming 50% is winning. So let's go ahead and go through this. HOHA, does he have 50 or does he have less than 50? Okay. So your spin acronym, we have a representative sample of voters. The population of voters is at least 400, which is 10 times 40. That might be about right in an ASB election. I'm not sure how many people actually vote at a school, probably around 1,000. Each vote is independent and the sample size is large because when I did my NP and N1 minus P, when it's 50%, it's the same answer. So, all right. So let's go ahead and run this through the calculator again, okay? So 16 out of 40 is what he's looking for. Okay. Stat tests, one prop Z, 0.5 goes there. 16 out of 40, well, 20 out of 40 is he's in the race, so this doesn't seem that unusual to me, but we're checking for less than. Yeah, this could happen by chance. The p-value is 10%. Okay, so that's definitely he should hang in the race. That sample does not show that he's out of it at this point. Okay, so again, it's better if you draw this out. So you're going to draw this, right? 0.5 goes there. 0.4 goes there. Here's your z-score, okay, which is negative 1.26. And the p-value is 0.103. Okay. So 10% is bigger than 5%. So there's not enough evidence. This could happen by chance. And again, kind of common sense is going to prevail a little bit here. Because, you know, if you get 16 out of 40 votes and you're hoping for 20 out of 40 to hang in there, that's not that big of a deal. Okay. So fail to reject. We have insufficient, and again, I'll write the word evidence to conclude AJ. So he should hang in the race. And this is a possible type 2 where that's down below there. When you fail to reject, it's possible type 2. Reject, possible type 1. Fail to reject, possible type 2. Okay. All right, next one, last one of the day here. Our cereal brand claims 25% of its cereal pieces is dried fruit, while the rest is grains. A random sample took a scoop of 30 boxes of cereal and found only 11% of its dried fruit. Okay, is the company misstating its numbers? Okay, so this is going to be a good one. You're going to see a couple things here. Here's your HOHA. It claims it's 25%. HA, we think it's less. The SPIN acronym, do you have a representative sample of cereal boxes? The population is at least 300. That's 10 times 30. Each distribution of dried fruit is independent. Sample size, if you notice, we actually do not have enough samples. We do not have enough samples to actually run a significance test. I put proceed with caution because the calculator will still do it. It's not like it won't produce an answer, but human reasoning says that you really don't have enough there. So in any event, let me slide down here and let me show this. If you do this, you will get a p-value of 0.0383. Okay, you will get that. And it'll be reject HO at alpha 05. So we do have sufficient evidence to conclude HA if we had enough samples, but because we don't, we really wouldn't do the test. But I wanted to show you one that suffered from low sample size. Okay, that is lesson 17.